Hello, I'm John Gertz, SETI theorist. You can learn about me at my website, johngertz.com, and read my peer-reviewed published papers. And don't forget to look for my forthcoming book with Oxford University Press entitled Reinventing SETI. In earlier videos, I tried to convey to you the impression that if ET exists, then ET is here right now in our own solar system in the form of alien robotic probes. But here the emphasis is on robotic. And why robotic? I keep saying this without necessarily explaining it. Now I will. There are no little green men in them. Why not? Traveling between stars is a very formidable task, either in terms of energy or in terms of time. In terms of energy, to go at anything like the kinds of speeds that would be required to get squishy beings like ourselves from one star to another star system would require fantastical amounts of energy. For example, if we took the very humble International Space Station, which is a tiny spacecraft, and we tried to accelerate it to simply 1/10 of the speed of light, then it would take a reasonable approximately 80 years to get to the nearest star system. It would take, the nearest star system is actually about 4.2 light years away, but it requires time to accelerate to 0.1 times 0.1 c or 0.1 of the speed of light, and the same amount of time to decelerate from there. To do that, to accomplish that, with simply the International Space Station would take approximately 50 million gigawatt hours of energy to accelerate to 0.1 c, and the same amount to decelerate upon arrival. Putting that in context, that's as much energy as the largest power plant in the United States would generate in almost 5,000 years. And that's just for a tiny spacecraft. And that's to go there in something like 80 years. Now, what if you wanted to colonize another star system? Well, a colony becomes a wholly other piece of problem. Let's imagine a colony of 6,000 individuals. That is a number I've taken from an aircraft carrier. That's about the number of people that live on sailors that live on an aircraft carrier. But this world ship, let's call it, going from here to another star system, is not an aircraft carrier. An aircraft carrier, first of all, has thin walls relative to a world ship, which would need the equivalent of 3 feet of concrete all around it simply for shielding. It would need space for all of the supplies because there's no stopping at a port of call anywhere in the middle of the trip. You've got to bring everything with you. You've got to bring all the water that you're going to require with you. You're going to have to increase the internal size of it to provide for agriculture, to grow the food that you're going to need. You can't possibly bring so much with you. And it would require much more space for living quarters because the living quarters on an aircraft carrier are all cheek by jowl. You can't expect someone to live their entire life like that. Now, if that world ship were traveling at the speed that our Voyager spacecraft travels at, it would need about 105,000 years to travel just to a nearby star called Barnard's star, which is only 6 light years away. 105,000 years would be more or less 4,200 human generations, every single one of whom would be born, live their entire lives, and die on board this world ship. Only the first generation and the last generation. How can you possibly keep a society stable for 4,200 generations without changing its form of government, without changing its religion, without the language evolving such that later generations can't possibly understand the owner's manuals that went with the first generation? What happens when there's a loss of required skills? What happens when all of the computer scientists in one generation are burned at the stake for being heretics? What about the balance of all the viruses and bacteria that one needs to start off with? The slightest out of balance or mutation can throw everything off. Let's look at the living quarters. I know that in my living quarters, I'll need a reading lamp. I'll need some pajamas, some bed sheets. I'm going to need a toothbrush and toothpaste and so forth. Are all 4,200 generations going to use the same toothbrush? No. I probably will go through 200 plus toothbrushes in my life. So will every other member of our crew. It's going to require a toothbrush factory and a toothpaste factory and a way to make linens and all the factories that require pharmaceuticals. And on and on and on. The light bulb, does it ever burn out? There needs to be a light bulb factory. As you multiply these problems over and over again, you find out that it's effectively, for all intents and purposes, impossible to transport civilizations from one star system to another. But if I'm wrong, and the crew manages to make it to the next star system, where's it going to land? The atmosphere on the next planet may be radically different than the atmosphere on Earth, poisoning us. The gravity, if the planet is twice the size of Earth or twice the mass of Earth, it'll have twice the gravity, and I'm going to weigh 350 pounds on that planet without the adjusting musculature to be able to make that transition. Won't be able to get out of bed in the morning. If the gravity is half of what it is on Earth, well then I don't know what that means long term. We know what microgravity does to the human body among astronauts, and it's not a very good thing. How's it going to be long term? Who knows? There's going to have to be surface chemistry that suits me and humanity, and we need potassium, iodine, sulfur, chlorine, calcium, magnesium, zinc, iron, phosphorus, and on and on. Will the surface chemistry of the planet be appropriate for us? Will its day-night cycle be appropriate? We exist in a 24-hour light cycle. We all know the havoc wrought upon the human body by jet lag or by shift work. These are real effects. How are we going to adjust to a day-night cycle that may be much different than here on Earth? If we have a 24-hour day, perhaps the other planet has a 7-hour day. So all in all, the difficulties in transporting a civilization from one planet to another is so daunting and so overwhelming now that I doubt it is ever really attempted. So consequently, I'm saying that the robotic probes that we meet here will have no little green men inside of them. Instead, they'll have AI intelligences that will be effectively ET's life form. We need to give them the deference that we would to ambassadors. I'm quite certain that they will pass the Turing test. In other words, in communicating with us, will have no idea whether they're squishy or silicon-based. That in effect they will be indistinguishable from intelligent life. So where Is ET itself? Well, Frank Drake, long ago when asked that question, said, well, ET is sunning itself pleasantly within its own solar system. And I think he's correct about that. But that's the subject of our next video. Thanks for tuning in. I'm John Gertz, SETI theorist. You can reach me at johngertz.com, where you'll find links to all of my published papers, and perhaps you'll look forward to seeing my book Reinventing SETI when it's published later this year. Thank you.